All right, let's try a quick example for concavity. So say I had the function f of x is x cubed. What goes off in your head when you think of x cubed?
Oh, that's the looks like a tangent line.
Yeah, this is the one that looks a little bit like the tangent function, right? So this kind of whoopty thing. This happens at 0, 0. Yeah? Okay, so what I want you to do is identify the intervals where this thing is concave up and concave down.
It's concave up at numbers above 0 and concave down at numbers below 0.
You guys see that? So just go get out your smiley faces. Right? Cut them in half and ask which pieces match. So like this piece here is, right? Like side A is pretty clearly matched to this side of this guy, right? And side B is pretty clearly matched to this side of this guy. Cool. So where is this thing concave up?
Above 0.
Cool. Yeah, so I wrote x is bigger than 0. Huh.
Do you care about at 0?
No, I don't care about at 0 much. At 0 is a transition, right, between concave down over here and concave up over there. So to say that 0 is either concave up or down would be a little weird, right? You guys see that? So I'm going to leave that thing out. But I do want to rephrase this inequality as an interval.
So it's x is less than. Or what about? I'll stop part of it.
Yeah, good. I just need to make it an interval, right? So this thing as an interval starts at 0 and goes to positive infinity. And I need open bracket on infinity, right? Because that's not a number, so it wouldn't make any sense for me to talk about it anyway. And this one, yeah, I said we weren't going to worry about that. So that's also going to get an open bracket. Where's it going to be concave down?
X is less than 0.
Perfect.
So negative infinity to 0.
So x is less than 0, which we would write as negative infinity up to 0. Open on both bits. Where is this thing increasing?
Everywhere.
Everywhere. You guys see that? Right? In general, if you kind of squint at this thing, it's got a positive slope, right? Really what I mean by if you kind of squint at this is any place, right? As you move from left to right, you're going to be walking uphill. You guys see that? So this thing's always increasing, but it's concave up from 0 on and concave down until we get to 0. You guys cool with this? Okay. Please note, the reason we use these is that later in calculus class we'll have a way to get increasing, decreasing, and concave up and down. Like we'll have a way to get that information. And so we'll have some kind of a like, okay, we'll know it's increasing, decreasing, increasing or something. And then we'll have a up, down or something. You guys see this? Like if I have these two pieces of information, then I can use these as building blocks for functions. And I can draw the graphs of functions using these as my building blocks. Right? This is decreasing concave up. So any place I have a decreasing here and an up there, I'm going to put one of those. We could go through this process. You guys want to see what that would look like here?
Yeah.
This is, so warning, this is not a thing I expect you guys to be able to do at the end of this, because you won't have a place to get those. But for future reference, we just do this. Go, okay, I'm going to dash the important bits on my diagram here.
So those would line up. The timelines, at least, would be the same.
Yeah. So, yeah, you would have to make them line up.
Okay.
How did I don't know what you're doing.
Okay, so what I know is that my function's increasing until I get to this value, and then it's decreasing until I get to this value, and then it's increasing from there on out. And then somehow else I know that it's concave up until I get to here. It's concave down for a bit, then it's concave up for a bit, then it's concave down for a bit. So if I'm going to add this up, in this segment right here, it's increasing and concave up. So which one of your four pieces looks like increasing and concave up?
The right.
So,
So it's got to be concave up, so it's in this one, and it's increasing, so it's that one. So my picture is going to look like that in there. And then it's going to be concave down and increasing. So concave down is these two, and that's this one. So I just connect that on there. Okay, see that? Okay, then in here it's concave down and decreasing, right? So concave down is this side. Which one's decreasing? Right side. So I put one of those guys on here. Then in this next bit, it's concave up and decreasing. So which one's that? These are concave up, and I'm supposed to be decreasing. So that's left side of the smiley face. That's going to be this. Okay, see this?
Yeah.
And then this guy's going to be concave up and increasing. So that's right side of the smiley face. And then this other thing is going to be what?
concave down, increasing.
Concave down and increasing. So these are the concave down ones.
Left side.
Left side is the increasing one. So I get a function that looks like this. You guys see that? It's going to turn out that's actually a pretty good way to draw pictures. They really are just made out of these 4 bits as long as they're continuously differentiable. So as long as the function is reasonably nice, they're just made out of these. So you can just take these 4 bits and arrange them in the right order. Cool?
For example, if we had a parabola, would it just be double concave up and just double concave down?
Awesome. Yeah, parabolas are either this thing or that thing, right? So they're always either concave up or concave down. How do you tell? Yeah. Either the coefficient on the front is positive, in which case the thing points up and it's concave up, or the coefficient on the front is negative, in which case it points down and it's concave down. Cool. Good with that?